Welcome to our deep dive into the world of processors and motherboards. In this video, we'll explore the essential components that power every computer. Let's start with the processor, often called the CPU or central processing unit. It's the brain of your computer handling instructions, calculations, and managing tasks. Whether you're gaming, working, or just browsing, the CPU's performance is crucial. We'll break down what makes a processor fast, how it interacts with other parts, and why choosing the right one matters. So let's embark on this journey to understand what's really inside your machine. Now let's talk about the motherboard. Think of it as the backbone of your computer. The motherboard connects all the different components, including the processor, memory, storage, and expansion cards. It provides the pathways for data to travel and ensures everything works together seamlessly. Without a motherboard, your computer's parts would have no way to communicate. We'll look at the different sizes and features of motherboards, and why compatibility with your processor is so important. Understanding the motherboard is key to building or upgrading any computer. Let's get into the basics of CPU architecture. Modern processors are made up of millions, sometimes billions, of tiny transistors. These transistors switch on and off to process data. The architecture refers to how these transistors are organized and how the CPU handles instructions. Different architectures can mean big differences in speed, efficiency, and power consumption. We'll discuss terms like cores, threads, and clock speed and explain how they impact your computer's performance. Understanding architecture helps you make smarter choices when picking a processor. Motherboards come in different shapes and sizes known as form factors. The most common are ATX, Micro ATX, and Mini ATX. Each form factor determines the size of the board, the number of expansion slots, and how many components you can connect. Larger boards offer more features, while smaller ones are great for compact builds. Choosing the right form factor depends on your needs and the size of your computer case. We'll compare these options and help you decide which is best for your next build. Processors today often have multiple cores. Each core is like a mini processor that can handle its own tasks. More cores mean your computer can do more things at once, which is especially useful for multitasking, gaming, or creative work. We'll explain how dual-core, quad-core, and even 8-core CPUs differ and what that means for everyday use. Understanding cores helps you match your processor to your workload, ensuring smooth and efficient performance. One of the most important aspects of building a computer is making sure your processor and motherboard are compatible. This is determined by the socket type. The socket is the physical and electrical interface that connects the CPU to the motherboard. Different CPUs require different sockets, so you need to match them carefully. We'll look at popular socket types like Intel's LGA and AMD's AM series and explain how to check compatibility before you buy. Every motherboard has a chipset, which acts like its own brain. The chipset controls communication between the processor, memory, storage, and other peripherals. Different chipsets offer different features, such as support for faster memory, more USB ports, or advanced networking. Choosing the right chipset ensures your system has the features you need, whether you're building a gaming rig or a workstation. We'll break down the main chipset families and what they offer. Motherboards and processors work together to support your system's memory, or RAM. The type and amount of RAM you can use depends on both components. Some motherboards support faster or larger amounts of RAM, while others are more limited. We'll explain how to check memory compatibility, what dual-channel and quad-channel mean, and why having enough RAM is essential for smooth performance. This knowledge helps you avoid bottlenecks and get the most from your system. Motherboards feature expansion slots that let you add extra components like graphics cards, sound cards, or network adapters. The most common slot is PCI Express or PCIe, which comes in different sizes and speeds. We'll discuss what these slots are used for, how to identify them, and why they matter for upgrading your computer. Knowing about expansion slots helps you plan for future upgrades and ensures your system stays flexible. Some processors and motherboards come with integrated graphics, which means your computer can display images without a separate graphics card. This is great for everyday tasks and light gaming. However, for more demanding applications like gaming or video editing, a dedicated graphics card is better. We'll compare the pros and cons of integrated and dedicated graphics and help you decide which is right for your needs. BIOS or UEFI is the software that starts your computer and manages basic settings. It lives on the motherboard and controls things like boot order, hardware settings, and system monitoring. Modern motherboards use UEFI, which offers a more user-friendly interface and advanced features compared to traditional BIOS. We'll explain how to access these settings and why they're important for troubleshooting and optimizing your system. Motherboards have complex power delivery systems to ensure your processor and other components get the right amount of electricity. This is managed by voltage regulator modules or VRMs. High-quality VRMs are especially important for powerful CPUs or overclocking. We'll discuss how power delivery works, what to look for in a motherboard's VRM setup, and why stable power is key for performance and reliability. Modern motherboards support a variety of storage connections, including SATA, M2, and NVMe. These determine how fast your computer can read and write data. We'll explain the differences between these connections, what kind of drives they support, and how to choose the right storage for your needs. Fast storage means quicker boot times and faster file transfers, so it's worth understanding your option. Overclocking is the process of making your processor or memory run faster than their default speeds. Some motherboards and CPUs are designed for overclocking, offering special features and controls. We'll cover the basics of overclocking, what benefits it can bring, and the risks involved. If you're interested in squeezing extra performance from your system, understanding overclocking is a must. Keeping your processor cool is essential for stable performance. Motherboards support different types of cooling solutions, from basic air coolers to advanced liquid cooling systems. We'll discuss why cooling matters, how to choose the right cooler, and what features to look for on your motherboard, such as fan headers and pump connectors. Proper cooling helps your system run smoothly and extends its lifespan. Motherboards come with a variety of input and output ports including USB, HDMI, Ethernet, and audio jacks. These ports let you connect peripherals like keyboards, monitors, and speakers. We'll go over the most common ports, what they're used for, and how to make sure your motherboard has the connectivity you need for your devices. Many motherboards include built-in networking features such as Ethernet ports and Wi-Fi modules. These allow your computer to connect to the internet and local networks. We'll explain the differences between wired and wireless networking, what speeds to expect, and how to choose a motherboard with the right networking features for your needs. Motherboards often come with integrated audio solutions providing sound output for speakers and headphones. Some offer advanced features like surround sound or high-definition audio. We'll discuss what to look for in onboard audio, when you might need a dedicated sound card, and how audio quality can impact your experience, especially for gaming or media consumption. USB ports come in different standards like USB 2, 3, and the newer USB-C. Each offers different speeds and capabilities. We'll explain what these standards mean, how to identify them on your motherboard, and why faster USB ports can make a big difference for transferring files or connecting devices. PCI Express or PCIe is the standard for connecting high-speed components like graphics cards and SSDs. There are different generations of PCIe, each offering faster speeds and more bandwidth. We'll break down the differences between PCIe 3, 4, and the latest 5 and explain how they impact your system's performance and upgrade potential. Some motherboards include onboard LEDs or diagnostic displays. These features help you troubleshoot problems by showing error codes or lighting up when something isn't working. We'll explain how these diagnostics work, what to look for, and how they can save you time when building or maintaining your computer. Aesthetics are becoming more important in modern computers. Many motherboards feature RGB lighting, sleek designs, and color-coordinated components. While looks aren't everything, they can make your build stand out. We'll discuss popular aesthetic features and how to choose a motherboard that fits your style as well as your needs. Processors are released in generations, with each new generation bringing improvements in speed, efficiency, and features. We'll explain how to identify processor generations, what changes from one generation to the next, and why upgrading to a newer generation can boost your system's performance. If you're interested in virtual reality or high-end gaming, your processor and motherboard need to support the latest technologies. We'll discuss what features to look for, such as high-speed USB ports, powerful chipsets, and support for fast graphics cards. This ensures your system is ready for immersive experiences and demanding games. Not all processors are created equal. Mobile CPUs found in laptops are designed for efficiency and battery life, while desktop CPUs focus on raw performance. We'll compare the differences, discuss where each type excels, and help you understand which is best for your needs, whether you're building a portable device or a powerful desktop. Some motherboards and processors support ECC or error-correcting code memory. ECC RAM can detect and correct data errors, making it essential for servers and workstations where reliability is critical. We'll explain what ECC is, who needs it, and how to check if your system supports it. Some motherboards offer advanced ports like Thunderbolt, which provide ultra-fast data transfer and support for multiple devices. We'll discuss what Thunderbolt is, how it compares to other high-speed ports, and why it might be a valuable feature for creative professionals or power users. Keeping your motherboard's firmware up to date is important for security and compatibility. Firmware updates can fix bugs, add new features, and support newer processors or memory. We'll explain how to check for updates, what risks are involved, and why regular updates keep your system running smoothly. There are many motherboard brands to choose from, each offering different features, quality, and price points. We'll introduce some of the most popular brands, discuss what sets them apart, and help you decide which brand might be the best fit for your next build. Processors generate heat, and keeping them cool is vital for performance and longevity. We'll explore different cooling technologies, from traditional air coolers to advanced liquid cooling systems. Learn how to pick the right cooling solution for your processor and what features to look for in a compatible motherboard. Energy efficiency is an important consideration for both processors and motherboards. Efficient components use less power, generate less heat, and can lower your electricity bills. We'll discuss how to identify energy-efficient parts, what certifications to look for, and how efficiency impacts performance and system design. Some motherboards offer a BIOS flashback feature, allowing you to update the BIOS without a CPU or memory installed. This can be a lifesaver if you need to support a new processor. We'll explain how BIOS flashback works, when to use it, and why it's a valuable feature for builders and upgraders. Many modern motherboards come with integrated Wi-Fi and Bluetooth, making it easy to connect to wireless networks and devices. We'll discuss the benefits of built-in wireless features, what standards to look for, and how to ensure compatibility with your other devices. Some motherboards support multiple graphics cards, a feature known as multi-GPU support. This can boost gaming or professional performance by combining the power of 2 or more GPUs. We'll explain how multi-GPU setups work, what to look for in a motherboard, and whether this feature is right for you. The processor cache is a small, fast memory inside the CPU that stores frequently used data. This helps speed up processing by reducing the time needed to access information. We'll explain the different levels of cache, how they work, and why they matter for performance. Durability is an important factor when choosing a motherboard. Features like reinforced slots, high-quality capacitors, and protective coatings can extend the life of your board. We'll discuss what makes a motherboard durable and how to choose one that will stand the test of time. Processors are made using advanced manufacturing processes, measured in nanometers. Smaller processes mean more transistors can fit on a chip, improving speed and efficiency. We'll explain what these numbers mean, how they impact performance, and why newer manufacturing processes are better for modern CPUs. Modern motherboards offer advanced BIOS features such as fan control, hardware monitoring, and easy overclocking tools. We'll explore these features, show you how to access them, and explain how they can help you get the most from your system. Security is a growing concern in computing. Many modern processors include built-in security features such as hardware encryption and secure boot. We'll discuss what these features do, why they matter, and how to make sure your system is protected from threats. The layout of your motherboard can affect how easy it is to build and upgrade your computer. We'll share tips on what to look for, such as clear labeling, accessible connectors, and smart component placement. A well-designed layout makes building your PC a smoother experience. Processor names can be confusing with lots of numbers and letters. We'll break down common naming schemes from Intel and AMD, explain what the different parts mean, and help you decode processor names so you can make informed choices. Motherboards often come with accessories like SATA cables, I/O shields, and Wi-Fi antennas. We'll go over what these accessories are for, how to use them, and why they're important for a successful build. Benchmarks are tests that measure how fast a processor can complete tasks. We'll explain how to read benchmark scores, what they mean for real-world performance, and how to use them to compare different CPUs before making a purchase. When choosing a motherboard, it's smart to think about future upgrades. Some boards support newer processors or more memory, while others are more limited. We'll discuss how to plan for upgrades, what to look for in a flexible motherboard, and how to keep your system up to date. We've covered a lot about processors and motherboards, from the basics to advanced features. Remember, choosing the right components is about balancing performance, compatibility, and your specific needs. Take your time to research, compare options, and plan for the future. With the right knowledge, you can build or upgrade a computer that's powerful, reliable, and ready for anything. Thanks for joining us on this journey through the heart of your computer.